Okay, here we go. So, good morning, everyone. So we're going to go to derivatives again, but today we're going to do derivatives of radicals. And we covered them before. We really have. If I give you guys this d over dx of the square root of x, we said rewrite this d over dx of x to the 1/2 power. That's how I described it. Okay. Now, we take the derivative by taking the exponent and bringing it to the front. That's what we call power rule, because we're bringing that power down. So it's 1/2 x to, and we minus 1 from that power. Now, here's a hint that I normally do. Instead of writing 1, if it's a fraction, I just copy that fraction. Isn't 2 over 2 the same as 1? Right? So if I change it to the common denominator, that becomes negative 1 over 2 really fast. Now, to follow this up, we want to do chain rule to it. What is the derivative of the inside x? That's just going to be 1. Just as a reminder, we do chain rule for everything. It doesn't seem always obvious, but yeah, equals to 1 over 2 square root of x. If you take a look at what I did here, the negative brings it to the bottom, and the 1/2 puts it back in the radical.
Why do we subtract? Because the root?
It's a power rule. So if you look at the exponent, that's a 1/2 exponent. So we treat this like
Oh yeah,
any
we always
exponent.
subtract by 1, my bad.
We always subtract by 1 when there's an exponent.
What's with the multiply times 1?
That's chain rule. So the outside is my power rule, and the inside is my chain rule. And what's the derivative of x? That's just 1. So we almost never write it, but it's actually still there. Let me give you another simpler example. D over dx of x squared. You guys are going to automatically tell me 2x, right? But if you want to really do all the work, you bring the 2 down, you minus the 1, that's why it's 1, and you chain rule. What's the derivative of x? 1. So you don't have to write it. Okay? So to prove to you that a chain rule isn't everything, even when I talked about the derivative of sine x, yeah, by identity, the derivative of sine x is cosine x. I'm not going to make the mistake this time. But really what's going on is the derivative of sine on the outside is cosine, and followed by chain rule, leave the inside alone. Then the derivative of x is 1. Chain rule still applies. Okay. Now, I'm going to do the same square root problem, except I'm going to throw something else in there. I'm going to throw d over dx square root of sine. Okay? So we're going to do the same thing. Write this as d over dx of sine of x with a power of 1/2. So we do the power rule. That's 1 over 2 sine of x to the negative 1/2, because that's minus 2 over 2. Because we minus 1, really, that's really 1. And then we chain rule it. The derivative of sine is cosine. But I want to show you something kind of cool. The outside square root, it's still going to give us the same derivative. I want you to take a look at our basic problem here and our new version. They kind of have the same structure, don't they? And the reason why they have the same structure is because this square root is the same derivative. We're taking the derivative of that 1/2 power. So whenever you see the derivative of a square root, let's do this really fast now, it's going to be d over dx of the square root of x squared plus 2x is going to be automatically 1 over 2 square root, automatically. Okay, let me show you why again. 1/2 power of x squared plus 2x. The 1/2 goes to the front. That's why we have the 2 here. This 1/2 minus 1 becomes a negative 1/2, right? That becomes a negative 1/2, which means I'm on the denominator, and we just copy the inside. Followed by chain rule. So here is a perspective I have. Whenever you're taking the derivative of a square root, this automatically becomes all of this. Then we chain rule times x squared plus 2x. Whoops, sorry, my bad, I just copied. 2x plus 2. That is our chain rule. So rewriting it, you could go from starting to finish. So I would write fraction 2 square root of x squared plus 2x, and it'd be 2x plus 2 on top. You can simplify this by dividing out by 2, x plus 1 over the square root of x squared plus 2x. Simplifying that, divide by 2. Okay, let's do another problem. D over dx, the square root of tangent. What's the setup? Automatically, I'm going to write 1 over 2 square root of tangent x. That's the derivative of the square root, because that's a 1/2 power. That is my chain rule. That's the outer shell. Multiplied by the chain rule, secant squared x. Oh, that looks like a heart. Oh, how did I do that? Here's my ADHD kicking in. You'll have 1,000 hearts before the end of the day. Sorry, excuse me. Now, a couple of cool things is that if you know that you're going to do chain rule anyways, you could just jump to secant squared, because that's the derivative of the inside over the 2 square root of tangent x you were going to have. Okay, so d over dx, let's do another one, of the square root of, sine x cosine x. Ooh, this one's a toughie. Sorry. So it's automatically going to be 1 over 2 square root sine x cosine x. All right. Now, chain rule. Is there a quick derivative for sine times cosine? Unfortunately, it's just product rule. So just do product rule. Derivative of sine is cosine. Leave the back alone. Plus the derivative of cosine is negative sine. Leave the front alone. So you just have to rewrite that. And when we rewrite it, it's going to be cosine squared x minus sine squared x all over 2 square root of sine x cosine x. There is no thinking involved. It's just do the rule. If I'm multiplying two things, product rule. But I don't want to. Nope, too bad. Do it. Just do it. Okay. What if I write d over dx of 1 over square root of x? Okay. Is there a fast way for this? Let's see. If I rewrite it as x squared of x to the negative 1 power, you could do that, and it'll just be 3 chain rules. The first chain rule will be negative 1 square root of x, negative 2. How do you guys feel about this first step here? Okay. Then, step number 2, the square root. What's the derivative of the square root? I can automatically say that's 1 over 2 square root of x. Step number 3, inside, inside. The derivative of the inside is just 1. Okay, this is without simplifying. This is just me writing it out super fast. if I do d over dx of, okay, you know what? What if I wrote it a different way? What if I wrote 1 over square root of x is equal to d over dx of x to the negative 1/2 power? Will this change our answer? Is everyone okay that I can write this as a negative exponent?
Mister,
Yeah.
would you simplify the top answer more or no?
Yeah, you would definitely simplify it. If I want to simplify it, this is on the bottom denominator. So this will be negative, and it doesn't, so let me write it out so you guys can see it first. Negative square root of x squared times 2 square root of x, and that's it. Okay. If I simplify it one more time, it'll be negative 1 over 2x square root of x.
Mr. Ko,
Yes.
will there be, like, going forward, how often will you be asking us to just leave it as a negative exponent? Because on IXL, it asks that a lot.
It is not a wrong answer. And in
Okay.
calculus, a lot of times, like all the rules you learn in algebra 1 and 2, like don't leave the square roots on the bottom. Calculus doesn't care.
Okay.
Right? If it does say simplify though, if it says simplify, they want the nicest, most compressed answer possible. So just be aware.
Thanks.
Okay, cool. So I'm going to do this problem here, and let's see, does it give me the same answer over here? I don't know. Let's try. Okay, so the derivative of x to negative 1/2 power, that's power rule, so it's negative 1 over 2, and x to negative 3 over 2. How'd you do that, Mr. Ko? Remember, we subtract by 1, right? But I'm going to subtract by 2 over 2. And when I write a common denominator, it's a lot more obvious that negative 1 minus 2 is negative 3. Okay? We can rewrite this, negative 1 over 2, and I'm going to rewrite this as the square root of x cubed. How many x's are we looking for? For square roots, we're looking for 2. Well, I got 3 for you. So this takes out one pair. Negative 1 over 2x squared root of x. Same answer. So it's really a preference, whichever one you want to use. I think us changing it to a negative 1/2 was actually easy here. Okay. But you could have used our rule from before. That would also have worked.
Wait,
Same
Mr.
answer.
So for IXL, would you also be able to answer like that? Would it still take you like that? Because I'm not sure. Like
I would have to
when I was
look.
doing it, I was answering like this, where it was like negative 1/2 x and then minus 3 over 2. That's what I would get, and that's how I would answer it. But like, sometimes it says to simplify. If we were to answer like how you put negative 1 over 2x square root of x, would it still take it?
Yeah, that's a simplified answer.
Okay.
Okay, let's do another one. D over dx of the square root of x squared plus 1 plus the square root of 2 sine of x. Okay. This one looks a little bit trashy, but there's a hint to this. Since there's a plus sign, they're two separate problems. 1 over 2 square root of x squared plus 1, right? Just write that first. Times 2x because of chain rule. Plus 1 over 2 square root of 2 sine x. Chain rule. 2 cosine x. And then here's something that happens a lot. Because of squares, maybe because of 2's inside, you end up dividing that 2 out. So it's x over square root of x squared plus 1 plus cosine of x square root of 2 sine of x. Happens a lot where you end up dividing that 2 out. Super fast. Okay. So besides that, that's the thing about radicals. Now let's move to a different type of radical, So d over dx of, let's say, the cube root of x squared plus 2. Okay? Now we have a cube root. This can be rewritten as d over dx of x squared plus 1, or plus 2, I'm sorry, to the 1/3 power, because I have 1 out of 3, 1/3 power. So knowing how to do it multiple ways is important. Okay, so 1/3, that's the power rule. This is chain rule. There's a power. That becomes 1/3. And we're going to write x squared plus 2. Remember, we minus 1, right? So I'm going to write a different color for you guys. Minus 3/3, because this is the same as minus 1. So I like writing the fraction because it makes it easier on my brain. Negative 2/3. 1 minus 3 is negative 2. Don't forget to follow through with chain rule. 2x plus, just 2x. Now, again, just to help you guys out with chain rule, make sure you realize what's on the outside. This is my outside shell. Do that first. Copy the inside. Once you're done with the outside, we multiply by the derivative of the inside. Okay. From here, we can rewrite it. 2x is on top, 3 is on the bottom, and this is one ugly radical, the cube root of x squared plus 2 squared, because you have 2 out of 3. You don't have enough to come out of that radical. Okay, let's do that problem again. So d over dx, the cube root of sine of 2x. Okay, this is going to be a triple chain rule. Triple attack. Okay, so if you've seen the pattern already, if I write this as sine 2x with a 1/3, right? Don't you always end up with a 3 on the bottom? Because it's 1/3. And when you minus 3/3, don't you always end up with 2/3 left? So you're always going to end up with your radical, your fraction in the front, and 2 left over. When you do chain rule, we're going to say the derivative of sine is cosine. Leave the inside alone. Leave that 2x alone. You're just copying it. It's just hanging on to the right. If you want, you can draw your little shells, right? Those are your shells. And then we multiply by the chain rule 2. Rewriting this, 2 cosine 2x over 3, the cube root of sine 2x. And you can write square there if you want to. That's like the prettier way of us learning how to write it in pre-calc. Okay. Let me pause. Okay, let's try this dummy problem. The derivative of the 4th root of e to the 5x. So let's pay attention to a couple things. The outside shell is the square root of 4, the 4th root, and then followed by the e, then followed last by the 5x. Okay, this is our plan. Rewrite this if you need to. If you don't need to, great. I'm going to rewrite it so my brain has to think less, because that's a 1/4. Okay, that becomes outer shell first, the derivative of the 1/4. 1/4 first. That gives me 1/4 e to the 5x. And since I'm minusing 4/4, right, that becomes negative 3/4. Next part, the e to the 5x. The e part. The derivative of e is always itself. So e to the 5x. Done. Next part. Next level, the 5x. It's just going to be times 5. Okay. Now we can rewrite this here. And there's some algebra 1 and algebra 2 coming along. So we can write 1, not 1 over. We have 5 e to the 5x all over 4, the fourth root of e to the 5x cubed.
Mr. Ko?
Yep.
I have to go take for the pictures.
Yeah. Have a good time.
All right.
Make
thank
sure you smile.
Yes. Thank you.
They strictly prohibit smiling in pictures.
Oh, sounds like a
Is that
passport picture.
Is that Andy who just went?
Yeah.
Okay.
Okay. Now, you can actually simplify this. If you guys remember algebra 2, like you could simplify it right here if you wanted to.